Around the world, a global housing crisis is developing. We're on track for more than 3 billion people in the world not to have adequate housing. Traditional software tools have really mostly just automated the bespoke nature of making buildings the way we've been practicing it for hundreds of years. What if there was a smarter, faster way to make building decisions? Today on the podcast, we're going to talk about what it would look like to make a set of software tools that radically change how we design buildings, how we construct them, and how we take care of them afterwards.
Could we make well-designed architecture accessible to everyone by using AI, by using data sharing?
There was kind of a light bulb moment where we started to unpack what both breakthrough technology and a radical solution could really look like.
The computing power, AI, people in the industry being much more open for this. It's a new day.
I'm Astro Teller, your host and captain of Moonshots, and this is the Moonshot Podcast. Joining us here is Michelle Kaufmann, who will never admit it to you, but is a world-famous architect, was with us at X for a long time. Welcome to the podcast, Michelle.
Thank you so much for having me. It is so wonderful to be back here with you.
Would you start by going back like 8 steps? You're a young, eager beaver coming out of your time at Princeton, and you get your very first job with arguably the most important architect on the planet, Frank Gehry. Tell us a little bit about how you started to develop as an architect, some of the philosophy that you've developed, particularly things that you've kept with you.
His buildings at the time were really the first time of doing these big grand gestures with big curved shapes made out of titanium and stainless steel. And yet, what I learned there is very first principles. And what's the simplest way to build a thing? During the time that I was there, this was the late 90s, Frank Gehry's office had just completed the Guggenheim Museum in Bilbao, Spain. And I went to the opening of it and saw people go into these spaces and they would literally start weeping, just being overcome with the beauty. It's like things that we've never experienced before. And then I was hooked. Oh my God, so architecture can have that kind of impact on people. This is incredible. I'm all in. However, at the same time, I had just gotten married to my husband, Kevin, and we thought, okay, let's find a house where we can live together. We could not find anything that we could afford that had even a drop of beauty or healthy materials or having nature and design. And so it was these 2 really different parts of my life that I cared about so much. And there was such a huge valley between those 2 that seemed almost overwhelming.
So what did you build? I mean, I've been to it, but tell us what you built.
So my husband and I then just thought, okay, well, maybe we can just build something for ourselves that is small but well-designed, that can produce its own energy, and we'll think about natural materials. And so we designed this little house, and we love it. We still live in it, and my husband built it. But as we were doing that, we had friends and colleagues who said, oh, that's cool. We also can't afford a house. Like, can we have something like what you're doing? And this was at a time when prefabrication had just come alive again a little bit. Prefab is really the oldest new idea there is. And so this
Prefabrication of homes.
Prefabrication of homes in large chunks.
And you started a company.
After we were in design and we just started construction of our house. And this is when we had friends and colleagues who said, oh, can you do something like this for us? And so I started meeting with factories. Could we do this? Luckily, we found a factory who could build it. And we just had so many people and so much energy that just, we're like, yes, this is the right thing to do.
So you start a company to make homes people would actually love in a factory. And that company is ramping up. And then the crash comes in mid-2008.
Yes.
Tell us about this crisis moment.
We were really busy. We had a lot of incredible clients. We had a couple of factories that we were working with. We also started our own factory too. And we had 2 factory partners go out of business within the span of 2 weeks. We had millions of dollars of projects in those factories. We had, at this point, maybe we were 25 people. that was too much for our company to handle. So we had to close. And it was by far the most painful thing I had ever experienced in my life to that point, because I had always tried to excel at everything. And my biggest fear was failure. And I remember talking to Kevin and I was like, I guess I'm over. Like, you can't fail at this kind of scale and still exist. And luckily, I had someone who I was doing a house for, who introduced me to Sebastian Throne, who you had on the very first podcast of season 1 talking about Waymo. And he called me one day then and said, we started this group within Google, and I have a partner, Astro Teller, and he has this pretty kooky idea about architecture in a moonshot. Can we have lunch? Can you please talk sense into him? This just seems like a really bad idea.
And so did you talk sense into me?
You start telling me about your idea of a moonshot. Could we make well-designed architecture accessible to everyone by using AI, by using data sharing? How might we embed best practices into something that can be holistic and integrated? And as you're talking about this, I'm like, oh my God, things I was trying to do with our company to make well-designed homes accessible to everyone. And I thought we did an incredible job by building 54 homes in multiple states, but that's like a drop in the bucket to what you were talking about. You were like, we could help millions, we could help billions of people. What if we, and as you started talking about this, I was like, this is the best idea I've ever heard. Poor Sebastian. Sebastian kept trying to throw some wrenches in the system, but then you and I kept riffing. So by the end of that lunch, I think you realized you were stuck with me.
I think I might literally have offered you a job by the end of that day.
Yes, exactly. But I will never forget that lunch. It was transformational for me.
So you joined this team. What the team internally was called Genie. This was the first run that X took at trying to help architecture and engineering and construction have a software system that in a really holistic way could automate the process of getting a building permitted, designed, constructed, and approved in a way where the whole process involved a system that would allow you to understand in real time all of the ramifications. Because as you knew better than almost anyone on the planet, the reason it can take 5 years to build a building and cost 2 to 3 times what everyone thought it was going to cost is because you're kind of slowly learning along the way all of the realities of the details of what this building is going to take.
Yes, it's crazy and a little embarrassing. And what I realized through that process too, really hard for smart engineers to even believe is still really the reality of things, which is every time we do a building, even though there've been millions of buildings built before, it's as though we've never done a building before. Because somehow, even with the smartest folks on your project, it always happens. You design it, you have some idea of cost, you think you do, and then you go to permit it, and you have to make changes. And so by the time you've ended up with a thing, it's taken way longer, it's costing much more. Hopefully it's worth it, but it is not for the faint of heart.
So tell us a little bit, you joined a very small, this Genie team when it was still quite small, and then you helped us to start to grow it. Was it a normal team? Would you describe it that way?
We were a small, scrappy team. There were a handful of very smart software engineers, and we were basically learning each other's languages, which is fascinating because software engineering, as you know, originally was modeled somewhat off of architecture. But architects, especially at the time when we started this moonshot, we're not thinking about software other than, hey, what's a tool I can use? I remember you and some of the team members are like, okay, Michelle, let's understand the algorithms of this. And I was like, algorithm? What do you mean? I don't know an algorithm. But then you helped me realize, okay, an algorithm is just understanding a process with rules. Well, oh my gosh, that's 95% of architecture is process and rules. It's all algorithmic. And that was your big moonshot idea. And so it was really interesting working with this group of software engineers. We were teaching each other. It was really interesting too, is a lot of our words had 2 opposite meanings. Code, 2 totally different meanings. Developer, two totally different meanings. And so some of it is we also had to make our own dictionary, if you will. And then we also learned about each other's ways of approaching problems. And as we were doing this in the early prototypes, which were very simplistic, all of a sudden it felt magical of, oh my gosh, I could put these parts in it. And even though the early prototypes were not a building we would want to build, but oh my gosh, then it has cost right there. And if I begin to move this and move this, the cost then changes immediately. Oh my God, like this feels like superpowers.
Right, because I don't think it's immediately obvious that if someone had an idea for a building at that time, to some extent still true today, sadly, you would then have a number of people like you and structural engineers and others go spend at least months to work out a detailed plan for the building, and then you would come back many months later and say, this is how much that would cost.
Yes.
And then usually the person who has to pay that amount of money says, well, no way I'm going to pay that.
Yep.
And then you have to do your second round of
That's right.
well, what do you want instead? If each iteration takes 3 to 5 months minimum,
yes,
then there is no innovation cycle because you can't afford more than 1 or 2 cycles of that in the building process. And what we were presenting was, what if you could do hundreds of those iterations in the same first couple of months of getting towards making your building?
That changes the game. Yeah. Because then I actually can have really good information that I really need while I'm designing. I've never had that before.
So a couple years later, Genie is graduating from X. It's going to become an independent company outside. And you went with it to go be one of the founders of this company. We had this product now called P12. That was the internal name for it. When some of our early users were using it, what were they experiencing? What was it like by then?
And we were, I think, the very first spin out from X.
Yeah.
We had a really good working prototype. And one of our very first projects that we did then, after we started this company, Flux, was to design and build an office building within 12 months.
Hence P12.
And we called it P12.
Yeah.
And we're like, yep, we can do it. Let's try. And so we brought together this cross-functional group, and together then we were creating algorithms where then we could say, okay, I want to prioritize user experience, like have everyone have views no matter where they're sitting at their desk, want it to be a healthy building, and oh, guess what? We really need to optimize for speed and the construction cost. You could set those priorities. You could pull up then the system, put in your address,
and
boom, and you would have an immediate building auto-populate for you. It's like, whoa.
When you say immediate, you mean like 10 to 60 seconds, maybe, in the system. What would that normally have taken to get to the same detail if you had asked an architecture firm to make that for you?
It would have taken 5 months to get to that, because even though it looked like, okay, cute massing, but then you could double click on a different tab. Oh no, that's based on actually fully engineered like profiles of the structure, of the heating and cooling systems. It actually was pulling in and testing then that to make sure that it met fire requirements for exiting. But here's the really cool part then, is it gives you the cost, and then I could sculpt the building because I want to spend my time on the magic. And then I might be like stretching it a little bit further, like, oh, I want this. All of a sudden, oh God. Like now it just added more stairs and like another bathroom. Like, oh God, and the cost just skyrocketed.
The problem is there are laws about things like you can't walk too far to get to a fire exit. If you started to stretch a building, for example, in one direction, all of a sudden one staircase turns into 2 separate staircases. That's why the costs are going up. So this intelligent clay that you're mushing is actually filling in these second, third, and fourth order ramifications of your mushing in real time.
And that's one of the keys here, because I wouldn't have found that out until months later. And it would have had a huge cost impact down the line. And then I would have had to change it, et cetera. Because in the normal process, even with the smartest architects and engineers and builders, there's no way a human can hold all those data sets in their brains at one time. It's just not how our brains work.
So this company, Flux, was out in the world for quite a number of years. Ultimately, it kind of went sideways. There's going to be sort of a happy end to this story. But why do you think that Flux ultimately wasn't super successful? Was it just too early? Did they have, it was the wrong moonshot to try?
So I'll start with P12. And we were 90 to 95% complete with this fully functioning model. And what we found is even as we were working with really innovative developers doing buildings, they all have systems, they all have processes they'd been using. And for them to do anything different meant huge risks. They are all like, cool, tell us after you've already done it with another developer. And so it was this kind of hump to get over that we needed to make a thing that was going to be really great for developers, but we couldn't really do it with a developer because they needed to be doing their standard systems. In the end, I think it was ahead of its time. It was also ahead of the technology because computing power required to pull in all these massive sets of data wasn't quite where it is now. It was also probably too early for the industry too. So that's what's so exciting about today, is today, all of those things are in a really different place. The computing power, AI, people in the industry being much more open for this, it's a new day.
We're going to get back to that in a minute, but as you were describing, all of these other builders weren't quite brave enough to go first, and Google was actually too brave. They wanted to do something really big and crazy, and ultimately, you came back here to Google to become the director of research and development for the lab for the built environment for Google, and you became the person who oversaw the bravest building that Google has built today. Actually, several now of the bravest buildings, but many people have seen the new headquarters for Google. This sort of looks like a big top tent. Tell us a little bit about coming back to Google and about what you brought with you back to setting up this lab of your own.
Well, there's no way that lab would have existed without X. We started off in a storage shed, which didn't even have windows, didn't have heating or cooling, but we had this high level of ambition and belief that we could do this thing. So we hired the most incredible cross-functional engineering team. And they would all come to town and we would meet up in our storage shed. And we had to go back to first principles. And this is what I learned here. You start with the simplest way to make a thing out of duct tape or whatever to test the problem. And this is also because to do these really ambitious things, it's like we have to respect the laws of physics, but everything else, let's assume we can figure out.
Tell me about what you were feeling as you came up the elevator here today.
I go in the elevator. Oh my God, there's disco balls on the ceiling of the elevator. There's hanging metallic drapery on the sides. There's literally mirrors on the floor of the elevator, and then there's disco music playing. So Dancing Queen is playing. I start dancing in the elevator. By the time I get up here to the third floor, I'm dancing, basically until I've seen you, I've been dancing. It's these delightful, surprising moments that just bring joy. And that is also something that you and this team has helped me really realize is how important play is and fun and joy. Because when you're working on these tough problems, you need that joy and you need each other to help solve these things together, to help you not give up when things can feel like a failure.
Thank you for doing this with me, Michelle. So grateful to you.
Thank you so much.
Now we're going to talk about what happened with that Moonshot compost of ours. Over the last 12 years, we've come back several times to how we can address this housing crisis, and I think we may have finally cracked the nut. Join us next as we talk to Adrian Walker and Julia Ling, the leaders of Anori. We're going to be talking to them about how we've taken everything we've learned from Flux, capturing this current wave of artificial intelligence and machine learning, bringing it all together in what we think is now the right way to set up a software system so that buildings can be designed, built, and managed in a much faster, cheaper, and more sustainable way. Welcome, Adrian. Welcome, Julia.
Thank you. Thanks for having us.
Thanks for having us, Astro.
X has been exploring how to help the built environment using software for almost 14 years now. We had Michelle Kaufmann, who's an advisor to Anori now, talking about our very first exploration into this problem area. Can you unpack a little for us? Like, does this matter? Does it need a moonshot?
We believe it does. This problem is so big, Astro. There's a massive labor shortage. So a lot of the people who are the most senior people who know how to build things, over 30% of them are planned to be retiring in the coming 5 years. You have a lot of supply chain issues and material costs that are skyrocketing. In addition to that, the process of how you actually bring a home or a building to market has so many complex factors, so many different stakeholders, a lot of friction points of reworking or waste in the system, so much so that there's estimated in every single building 20 to 25% contingency, which is really a factor of waste. Real estate is one of the leading factors in the world, according to the UN, for its CO2 emissions at about 37% or so. And it also is the largest user of energy in the world. And the other one that we were really looking at, we'll call it the asset resiliency crisis. It means that today we were estimated at about 4 to 5 million of shortage of housing units in the United States of America. In the next 5 years, it's expected to double. And on a global scale, there's an estimated 250 million units of homes that are the shortage for the population today. So there's these problems percolating in our minds as a team here at X. And there was kind of a light bulb moment where we started to unpack what both breakthrough technology and a radical solution could really look like.
You partnered up with Julia as your CTO for this effort. And Julia, we're going to talk about what it might feel like, what it might be like to make a software system that addresses some of these things. But let's just get a scoping on this. If I was trying to go make an apartment building, I could meet with someone who would help me buy land. And there's like lawyers involved and bankers, and there's people who are like specialists in helping me figure out whether that's the right land to buy. I'd have to work with an architect then. Then I'd have to go find a general contractor. I'd probably end up hiring like a landscape architect and maybe an interior architect as well. And there's like structural engineers for a bunch of things. Which parts of that would your software system be doing? That's a lot of stuff.
It's true, that's a lot of stuff. And part of our approach is always to embrace that complexity up front and to drive straight at the hard problem first. We have text data and image data, definitely, but also geospatial data. So for example, if you are planning a new site, you need to know what are the soil conditions, what are the hydrology conditions. You want to know about regulatory conditions, and there's often parking restrictions, et cetera. So what's fundamentally been the meat of the problem for this use case is that we need to create the underlying language. From day one, our approach has been how are we creating a platform that provides wins for insurers, for banks, for developers, for architects and structural engineers, for the permitting offices and municipalities. And that's part of what makes this a moonshot.
You're talking about using tools from artificial intelligence to bring all this stuff together to solve this kind of end-to-end problem. For people like on the outside looking in, I can go to like Gemini right now and say, make me a house, and it'll draw me some pretty cool looking house. And if I say, no, I don't want a house, I want an apartment building, it'll like make me an apartment building. And if I say, make it 2 stories taller, it'll make it 2 stories taller. What are you talking about that's not that?
First of all, I think that kind of AI-generated imagery is super powerful for helping people imagine. But it's very different than an engineering drawing or an engineering design. What's different about our approach when we use AI is we're not generating images, we're generating specific geometry, specific graphs, specific representations that are engineering specific enough that you can actually say, this is what it would look like, and we're going to also run it against specific regulations. And we know decimal precision what is the setback here? What is the height here? So you can actually check that it's following those regulations.
Can you describe a little bit like a before-after picture of if you did it the way it's done today, and then using the Anori system just so people can have kind of a comparison in their minds if they were trying to build an apartment building?
Sure. So one of the things we've heard from multiple different stakeholders we've interacted with, both architects and developers, is that depending on the building complexity, going from site selection, where you say, here's the parcel I want to work on, to just a conceptual design that's a high enough fidelity to be able to do a financial due diligence analysis can take multiple months. Our approach is to try to bring as many of those constraints to the forefront as possible, especially the coupled constraints. So what often happens right now is that you have a sequential process where a developer might hand off constraints to an architect, who might hand off constraints to a structural engineer, who might hand off constraints to a mechanical engineer, structural engineer, plumbing engineer, et cetera. And through that extremely sequential process, you might end up at a dead end, right? And so for all of these constraints that are coupled, we want to pull those to the forefront so you can guarantee from the get-go that you're going to be able to solve for all of them instead of heading down a dead end in that maze.
You're saying like people should like front load all the constraints and solve for them all up front. But that seems so right, so obvious when you say that. Like, why doesn't everybody do that?
It's really hard to get everyone to work on the same designs at the same time because they're all working in different systems and solving for different metrics. That's a large part of the problem. And it's a problem not only because it takes longer, but it also stymies innovation. So you can imagine that if you're trying to be part of the current process and you know that if you hand off a set of constraints to the next person and they can't solve it, that it's going to come back to you and it's going to double your amount of work, then you're going to try to pass them the exact same thing you passed them last time that worked, right? Which means that you end up with a lot of buildings that look very, very similar, even if they're dramatically suboptimal. And if we think about the current housing crisis, we think to ourselves, we need to build a lot more, but we shouldn't build it the way we've been building it so far. We need to be innovative. We need to think about new materials. We need to think about more resilient site plans. And how is that going to be possible if we're always trying to pass through things through the old channels?
The copy-paste isn't
Exactly.
working. So you're talking about using tools from artificial intelligence to bring all this stuff together to solve this kind of end-to-end problem. So would it be fair to say that you're hoping that your Anori system will allow someone, a regulator, who has 100 pages of rules about what the building has to be and 100 blueprint-looking kind of in a stack from the developer about what the building they want to build will allow them to sort of automatically compare these two things and quickly get a yes, it's good or no, it's not good?
Absolutely. For the first time in history, we hope that that process could be automated for them. This platform is a cloud-based platform that they can log into, and when they log into it, they're going to get to an interface where it says, here are all the things in that application that checked, and here are the things that didn't, not just didn't work, but actually take you to the part of the regulatory code to say this is exactly where it broke the rule.
That sounds like you're doing 95% of their work for them, actually. When I think about trying to compare all of the regulations on file with some really complex building, that can take months sometimes. Are they going to be happy or sad that you're doing most of their work for them?
So far, all of them have been quite excited. They, you know, when they got into their work and what we continue to learn about civil servants and public servants is there's a lot that's actually on their plate. So if you said, look, you know, that backlog, that stack that's in your backlog, we can get rid of that, right? So, you know, automating away the tedium at 95% or whatever that is really just frees them up to really get to the other parts of their work that are so important as civil servants.
And to add on to that, a lot of the people in these zoning and permitting departments, they are really motivated by a few key factors. One is they want to help solve the housing crisis in their city. And two is they want to make sure that the buildings that get built are safe, right? And if you think, hey, we're going to be able to help them with both of those things, not only that, we're going to potentially be able to let them do scenario planning so that they can say, what if we changed this policy? What would the impact be on the types of buildings that could be zoned and permitted in this space? And being able to bring data into that picture just makes it so that they can do the job that they all came there to do, which is to help us build more buildings and safer buildings.
Have you actually started to work with developers or municipalities? Like, what's your learnings as you started to get out into the world?
We're going to be stepping in for the first time to do what we call kind of these pilot builds, meaning the first kind of AI-assisted platform buildings. And we're planning to do that, Astro, just within this next year, really kicking that off in earnest.
I know you've been out there working actively to learn from the world. Give me an example or two like that.
One of the things that's also challenging about buildings is that they're not one size fit all, right? And they come with a cultural significance. And so one of the things we've taken really seriously is meeting with people from around the world to understand those cultural contexts. And in fact, recently we were in New Zealand. We were hosted by some of the Maori leaders there. And one night they took us on a night hike with no flashlights. It was just through the dark, moonlit. And they took us to this steep embankment where you could actually see these glowworms glowing like a constellation of stars along this embankment. And he said, you can only really see this in places where it's truly dark. In many places in the US, you think, it's important to provide light, right? People drop their keys in the parking lot. They need to have a light to find it. But in some places in the world, it's also important to provide dark. And so I think that one of the things that we think about a lot is how can we create not just buildings, but buildings and homes that make sense in the context in which they're built.
In the context of which they're built, that's community. And every community has things that are very important to them and that they want to see within that design. And so that aesthetic and that feeling, that emotion that people get when they're really in a beautiful building or they're in a space or a community that works for them, it just changes everything about that community, the health of those people, and everything around them in that world. And that's what we're excited about.
Can you give us 2 or 3 of the places where you think that it'll be sort of the first places that these buildings get built?
The United States is going to be one of those places, we hope. But internationally, we're seeing a ton of excitement as well. Places like Rio de Janeiro in Brazil has a ton of excitement around this right now and working with us. Also places like New Zealand, Australia, places in the EU. A lot of the places I named are very impacted by weather patterns and have seen a lot of destruction in their countries and trying to figure out for themselves, how do I rebuild better and more efficiently and more cost efficiently? So we would expect them to be highly cynical. There's absolutely no way. This is too good to be true. There's no way that a new technology might be able to allow us to bring buildings into market in less than a fraction of the time and cut out, who knows, 30, 40, 50% of the cost and what that means for people, what that means for the affordability that they would have in that. So that's the part that's exciting is it's now. It's now.
Like all moonshots, this one is really hard. It's really complicated. What keeps you going?
Well, this is, I think, a deeply personal problem for a lot of our team members, including myself. I mean, there's really not any one of us that doesn't know someone who doesn't believe that they'll own a home one day, that they'll be a part of a community where they have ownership in it. So I think it's deeply personal for people.
Yeah, I think from my perspective, there's just nothing more fundamental than shelter, right? That's when you think about what people need, what basic human needs are, shelter ranks pretty much near the top next to oxygen, right? And the other part of it is this is one of the most fundamental ways in which we have an impact on the world around us. The things that we build, the buildings we build, have a tremendous impact on our planet. And so we really need to be thinking responsibly and conscientiously about how to do that right and how to do that better.
Let's say you nail it, and this is all working exactly as you described a decade from now. Are you done? Or could this expand in other ways? Like, is this applicable beyond just apartment buildings?
Absolutely. We actually believe it's real estate agnostic. The team has strategically chose to start in the residential and housing market. We're actually actively testing commercial properties, things in hospitality, things in retail, things in industrial, warehouses, any real estate asset, any physical building that needs to get built, and anything that is in the natural landscape around that. This platform is really built to address those needs.
I really appreciate your time here today, and it's just super exciting to see everything that Anori has built and watching you spread your wings and sort of get out into the world to start make some of these early buildings. Congratulations to you both, and thank you.
Thank you for having us.
Thanks, Astro.
The built environment creates 1/4 of the world's solid waste. It amounts for 1/4 of the world's carbon footprint. There are very few things that are more important to humanity than the buildings that we designed, build, and spend our lives in. And finding ways to make them faster, to make them cheaper, to make them healthier for us, to build them in a more sustainable way, there is really no bigger problem that we could be working on. I'm really proud of the work that's been done here at X by these and other amazing people, and I'm excited to see what they do next out in the world. Next time on the Moonshot Podcast, water is the most abundant substance on Earth, and yet people around the world don't have enough of it. We're going to talk about two very different and yet weirdly related what-ifs, both about water.
I think it's just so rare to have a scientific moment where you're literally turning a valve and a substance is coming out and it feels like a miracle.
It was like literally this save the world juice.
That was something that just like really stuck with us because that directly related to the good that we could do in someone's life with this.
This is the Moonshot Podcast, a peak action production for X, the Moonshot Factory, with me, Astro Teller. You can find more episodes wherever you get your podcasts and on our YouTube channel. If you want to take your own moonshots, we've developed a masterclass certificate course. Check it out in the show notes below. If you enjoyed this podcast, don't forget to subscribe. It helps other people find out about this series.